Okay, today we are going to touch on rate of change. Okay, and so because of the word rate, we are going to introduce the variable time. So let's say we have a height here given by this function. Now if you know that this function and you sketch it, right, it will look something like this. So I will have a height and then I have a time. So it is a U-shaped curve, but time cannot be negative, right? So I'll start from 0 and the U-shaped curve look like this. So this is the concept. So what do I want to find? I want to find the rate of change with respect to time. Again, this info is not really necessary because once you find the rate, means it's with respect to time. I say again. Later you see the questions, find the rate, and we will not tell you with respect to time because it is understood rate must be with respect to time. Okay, so find the rate of change when t is 2. So when t is 2, right? What is the rate of change? What do you think I'm finding at 2 there? Yes, so I was just looking for gradients only. Change in height over change in time. All right, so in this concept, because it is a continuous function, it's not a straight line. Okay, it is a curve. We will find dy dx. In this scenario, it is actually dh dt. Because your y is h, your x is t. So how do we do that? It's very, very simple. It's nothing new at all. Just the only thing that's new is the introduction of the word rate. Okay, so this is not the new part. So dh dt is simply bring down the power minus 1, bring down the power minus 1. So what do you think I do with t equals to 2? I just substitute into this function here, and therefore the rate of change of the height when t is 2 is equal 2 times 2 minus 1 is 3. Now, bear in mind, I'm more particular in this type of question. I need the units. So the units will be 3 units per time. Okay, I didn't put the time. Maybe here I put seconds. So it will be 3 units per second. So that is the rate of change of the height when the time is 2. Because the rate of change keeps changing, what? But when time is 2, the height is changing at 3 units per second. I give you a random scenario because I want to introduce something called rate of chain rule here. I want to introduce chain rule, so that I can do this question. All right, so this is the highlight of today's question. There will be 2 of them, slightly different only. Okay, V, let's call it the volume. T is the time. Obviously, T is always the time. And then I let X be the length. And any length, doesn't matter. So, why I box this in red? The most important is this part here. I will always start with this part. So, let's say I don't know what I'm finding. Okay. But I know there's a V and there's an X, right? You always start with this. Differentiate V with respect to what? X. Always start with this. Because this will be an equation later, you'll see in the examples, this will be an equation. You always differentiate this first. Now, you won't be finding. Yeah, later you will see. So if this is dt, right, what letter is on top? Okay, it will be the dx. So if I cancel, what will be on the left? dv over dt. So why do I do it in this sequence? It's because you don't know this side whether dv dt or dx dt. You don't know, right? So you see how the question got x, the question got t, and the question got v, right? So you will look at this example now, you have a better illustration, but this is called chain rule. Okay, so in order to find the rate of change of v with respect to time, I need to do this. Okay, it looks a bit blurred right now, but after this example, it will be crystal clear already. So from here, what will we get? You know that we want to find the rate of change, right? We know we need to use chain rule. So what do you think we will do with this? Differentiate. So it is called dy. This is all the tips I'm giving you on how to solve all these type of questions. It will become very easy, like super, super easy. So this one, logically speaking, with the confirm, we'll find dy dx. Okay, so this is the first process. You need to relabel the question. Now, there will always be a value given. Okay, for simple question, there's always a value given, like they'll give you x is 2, h is 5. So this one, highlight it and remind yourself, do this last. This is the last thing you put in. Now, rate of change of x, what will we have? dt over dx or dx over dt? Yeah, it's dx over dt. Speed is distance over time, what? Not time over distance. So rate is always over time. Rate is always over. Speed is distance over time. Okay, so it's always with respect to time. So it's a definition of rate. It's not time over distance, but it's distance over time. So by definition, rate of change of x is dx over dt. Now, do you realize that these words are no longer here already? It shouldn't be there because it's understood how rate is with respect to time, is understood. Now, what about this part here? The last part already. This is called d what? dy over dt. So do you see the chain rule?
Wait, so as long as it's rate of change of something, then that is d something over dt.
Yes, correct. When you see the word rate is dt below. Okay, now you see these three things. The confusion students have is how to put these three together. Actually, very simple. The rule again is the red box here. What must I put inside? This is the thing that's the life-changing part. Okay, so what do I put inside? It's the one that is don't have the t. So which one don't have the t? Okay, dy dx. Now the rest is common sense already. So if this is dy dx, what should this be? Because both remaining ones are t, right? You see, this one got t, this one got t, right? So both have t. So I know that this one got t. I know that this one got t, right? So what is down here? X because I want to cancel away. So if I cancel away, what is on the left? Dy. Now it is essential you do this method. Put the red color first. Then the t here, the t here. Why do I put both t? Because the remaining two parts of the question, they are all t, right? Okay? So, first step, find dy dx. Okay, so dy dx is simply using the chain rule, bring down the power minus 1, differentiate the inside, and I will have 15 3x minus 5 power 4. So this is what I mean by the red color part, last step. Do not sub in anything yet. Okay, I mean you have a tendency to want to do that, but don't sub in first. The 4/3, do it last. In case there will be some complicated question later, don't do it too early. Okay, let's put in the things. Do I have dy dt? Now you have to scan the question. Do I have dy dt? Do I have anything, any number, anything?
Yes.
I got dx/dt, right? But I don't have dy dt value. I got not yet. So let's put this first. Do I have any values here? Okay, so I put this first. So let's put it down here. So dy dt got no values. Dy dx I found already, right? So this is the one with, okay, let me put in red. This one I have. Now dx dt got any values or not? Look at the question again. Yes, that's a value 2, right? The value of dx dt is 2. Is means equal. So this is 2. So let's multiply in. I got 30, 3x minus 5/4. Now I want to find the rate of change of y at the instant whereby x is 4/3. What is the last step? Sub x is 4/3. So this is what I mean by last step. Let this always be the last step. So if I sub in 4/3 here, I got 30, 3 multiplied by 4/3 minus 5 to the power of 4. So this is simply just 1. Okay, you can press but it's 1. 30 times 1 is 30 units per second. Okay, final thing to observe before we pause the video and look at the second example. Can you see that this is per second? So this one will be one of the dt. Okay? If they never tell you it's the rate of change. If they never tell you it's the rate of change. But you see that the unit is per second. Then you should know that this number is for dt. Okay, first thing, tell me what do I label? Come on. Rate of change of x. Okay, you want to label this first. This becomes find dx dt. Okay. Next. Y is increasing at the rate of 3 units per second means what? D y over dt equals to 3. If you want to put equal to 3, you can. So this one given, right? That means I confirm find this one. Okay, even without looking at the question, you know this one got number, this one got no number, confirm is finding this. Now, usually, again, O-level will not tell you to find this. You have to find it yourself. How do I know I have to find this myself? You just look at this. Confirm is dy dx. Okay, I will write down the chain rule first because let's fill in the box. During your exam, don't have to draw the box. I just want to highlight this. So come, let's start. What do I put here? You want to make this easy for yourself? This one, the box will be dy dx, right? And this one show dt1, this one show got dt1 because the rest of the two lines, they are all having dt below. So what is at the numerator here? This one is dx. After I cancel already, I will have dy. Yes. So now, dy dt, I got a number, right? The 3 now is actually on your left-hand side. Okay, let's differentiate. If the differentiation is very complicated, you can do a side working, or you can differentiate first before you write down here. Okay. Okay, let's say it's very complicated. Let's imagine it's very complicated. So I just do a side working. Okay, I just do a side working. Because I don't want to use correction tape, I don't want to redo the thing. I got no more space. I do something called side working. Now the side working is y equals to x squared plus 9x power negative 1. I change to a polynomial form. Easy to differentiate. Okay, let's check. What is dy dx? 2x minus 9x power negative 2. Bring down the power minus 1. If you are able from here, look here, look at my pen. If from here, you can straight away write this. See what I'm writing. From here, I write this. That means you have practiced enough already. The day you practice enough, you can actually go from here, jump to here already. Okay? If can't, you have to do this one. Now the question is, must I write this one? No, I don't need to write. I write so that it looks nicer in the video. Later you see it looks nicer. Okay, I'm going to put this in now. 2x minus 9 over x squared. Okay, 2x minus 9 over x squared. Multiply by, look at the dx dt. Is there any number there? Definitely don't have. This one got number, this one cannot. So this one don't have any number. Why don't have number? Because this is the question. Find this. Now, just now I say, what was the last step? Sub the number in last. Okay, now let's do this last. So 3 equals to, this one is 2 times 3 is 6. 9 over 9 is 1. And this one I don't know. Okay, the last part. Yeah, just do the normal division, right? So the answer for dx over dt is, this is 3, this is 5. So the answer is 3 over 5, not 2. 3 over 5. And again, this one be a bit particular. Write down the unit, please. The unit will be units per second. That's the final answer, 3 over 5.